Hello friends, good morning. Today we are going to perform the next practical number 5, which is effect of shading on solar power generation. So as you know that whenever we are selecting the site and we came to know that the site is suitable for solar power generation because we are getting very good solar irradiations, in that case we have to also think about the future planning in that area by the government, like whether there is going to be a tall building nearby in early future, because the investment of the solar power plant is high and its payback time is around 2 to 3 years minimum, right? So accordingly we have to think of that it will not get the shading effect, otherwise the generated power will get hampered a lot. Also we have to check that whether there is any big tree which will shadow, okay, which will shadow our panels. So today we'll see how shadowing will affect on the generation of a power. So take down the first reading. So see, solar has risen, all solar radiations are falling on the solar panel. We have set the tilt angle and the generation at the present case is 37.5. Okay, so the first reading is no shade, that time our reading is 37.5. Now we'll provide the shading in vertical way. So I'll show you, you can take down the reading correspondingly. Suppose I will try to shade up this part. Say shade 1, reading is 31. Shade 2, 27.7. Shade 3, suppose this much amount of panel is getting covered, the voltage is reduced because that corresponding cells will not contribute in power generation. So reading is 26.3. Next reading, it is 27.7. Next reading, it is 25.6. Because see, whichever cells are coming beneath the shaded part, it will not contribute in power generation. Now we'll try to cover the another panel also, because whenever shade comes, it won't be on one panel only, as they are nearby. It may cover the other side also. Okay. Take down the next reading, next shading. The reading is 24.8. Next shading, 23.6. Next reading, 22. Next reading, 19. Next, 17.9. Next, 15.6. So here we try to shade the panel in the horizontal direction. Okay, now we'll see if shading is vertical, because number of solar cells are different vertically and horizontally in a panel. So it will also affect on the generation. So we have to take care of all the things. You can take down the next reading. Okay, suppose shading is like this. It is 20.8. Next reading 17.8. Next reading 16.3. Next reading 15.7. This is 17.1. So see, if the shade is at that side, at least these many cells which are getting the solar radiations are active. Okay. The next reading, suppose here there is no shading, and shading is due to a vertical tower placed at this side of the panel, which is covering only the left side panel. We'll see the vertical shading. Next reading one panel is not shaded, the other panel is getting shaded. So 34.7. Next one 30.3. Next one 26.8. Next one 28.0. Next one 28 volt. And as we know, no shading is there, it is 37.4. So I hope it is clear to you. There should not be any kind of shading by any of the way, not even because of overlapping of the solar panels to each other. Otherwise, though the capacity is there, we are not able to utilize the solar generation. Secondly, there should not be any big tower or any building or any tree or anything which will make a shade on the solar panel. So while site selection, it is one of the important criteria to find out whether there is going to be any kind of shading that we have to avoid to maintain the solar power. Okay, that's all for this experiment. I hope you enjoyed.